link to a class kick. I want you to open it because this is going to allow us to do some practice work together. So this isn't an assignment. It's not going to be graded, but it's what we're going to use to practice together on today's. Oh, thank you, Nola. I forget about BIM. Thank you. So go ahead and use that room chat link to click on the class kick assignment and open that up so that way I can see you and help you at the end of the lesson today. There's also a chart in there on the first slide. So everyone please open it, and then the chart, you don't have to write down the chart I'm going to put up in the notes today because it's already in there. So I wanted to save you a little bit of time in your note writing during class. So hopefully that is helpful to you. So while we wait for a few more friends to join us, go ahead and open up that link, and then I can actually see who's in there. So let's let's see. Okay. Let's see. Nola, I see you. Nolani, I see you. Marley, I see you. Okay, Amari, that makes sense. I get that. Well, hey, you could have $1 million maybe. You're not missing much, let me tell you. All right. So let me know if you're having trouble opening that. Sean, I see you. Rylan, are you able to open it? Logan, Ty, Karis, Noah, are y'all able to open that? Hey, Gabby. Yep, now I see you, Amari. Good job. Thank you. Hey, Gabby, if you want to go ahead and click on this link, I just posted it again in the room chat. It's also in the notes, but let's go ahead and get this opened up so that way whenever we get to needing it in a little bit, you will have it ready. Okay, so here's who I can see. Amari, Marley, Nolani, and Nola. So we're still missing quite a few. Let me know. Will you all send me a message if you're trying to access it or if you're having trouble? That way I can help you. Michael, are you able to get to it? Gabby, are you able to get to it? I can send it to y'all in a private message if that's helpful. So let me know if you need that. All right. So for those of you that have just joined us, I posted a link in the room chat. Oh, Gabby, good. I see you. Thank you. I posted a link in the room chat. It's also in the notes of a class kick assignment. It's not for a grade or anything, but I want you to be able to do the practice problems with me so that I can help you identify where you may be messed up. And then also there's a chart in there. So open that up so that way you don't have to write down the chart that I'm going to post. Awesome, Sanaya. Now I see you. Thank you. All right, so we're going to go ahead and get started. Today we're working on transformations to parent functions. So this goes with lesson 4.02 in your course. Okay, so there wasn't a homework assignment with this. So that's why we're doing this together in class. And then at the end, I'm going to send you to take your quiz over 4.02. So today's goal is we're going to be able to determine the effects on the graph of the parent function when f of x is replaced by a times f of x plus d, f of x minus c, or f of b times x for different values of a, B, C, and D. Okay, yay, Maurice, I see you. Thank you. So first, let's talk about some vocabulary to get started. What is a function or a family of functions? A family of functions is a set of functions whose graphs have basic characteristics in common. For us, right now, all linear functions form a family because all of their graphs are the same basic shape, which is a straight line. Okay, so we have different sets of families of functions, but all we have talked about so far is linear functions. So for purposes of algebra and what we've covered, the family of functions is going to be linear functions. So now this is where we're going to get into some specific vocabulary that you will need to know. Something called a parent function. So the parent function is basically the original. Okay, that's one way to think about it. It's the OG function. And what is it? Well, it's the most basic function. Okay, and the equation of this function is y equals x or f of x equals x. Okay, you're mostly going to see it as f of x equals x, but remember that f of x is just a fancy way to say y. Okay, those are the same. So we are used to writing functions as y equals, okay, we've been working on slope-intercept form of y equals mx plus b. Y is the same thing as f of x. Okay, the difference and the reason we're going to use this function notation, which is f of x, is because we're now going to make some changes to the original function and we're going to compare them. Okay, so f of x is basically just a name. So if you think about a family name, f of x would be like the parent function, so mom or dad. Then we're going to have g of x, so that would be like y'all. Okay, so it's just how we name a function. So what we're going to be doing is transforming our linear functions. A transformation is a change in position or size of a figure. Let's take a look at what the parent function looks like. So you know how to graph the parent function. You know how to graph all functions. Okay, so if the parent function, like we just talked about, is f of x equals x, let's break that down. To graph a function, we need the y-intercept and the slope. So let's determine what those are based on this equation. So in this equation, we have f of x equals x. Remember that the slope is the number in front of x. In the original parent function that I've highlighted in red at the top, there isn't a number in front of x, but that doesn't mean it's 0, because if it was 0, then x wouldn't be there at all. Okay, so that number is actually 1. And I know that's tricky, but think about it. If there is 1x there, then the number in front, the coefficient, has to be 1. So that makes our slope 1 over 1. So we're going to go up 1 and to the right 1. Then we need a y-intercept. Well, if the y-intercept is not listed, okay, then we can assume that it would be 0. So the parent function is going to start at the origin. That's the y-intercept. We're going to go up 1, right 1, up 1, right 1. We just continue. Okay, so this blue line is the parent function. Sometimes it will just tell you compare the new graph to the parent function. Okay, so think about it. What's the simplest function? We've got goes through the y-intercept of 0, has a slope of 1. That's what the parent function is, and you know how to graph that. So what's going to happen now that we're talking about transformations? Transformation, the graphs of all other linear functions are transformations of the graph of the parent function. So any function we are given that's a linear function comes from the parent function. We're just going to manipulate it in different ways. I'm going to pull up a chart. I want you to go in your class kick slides and go ahead and go to slide number 1. For those of you that need that link again, here it is. If you aren't on there yet, go ahead and open this up. Please open it because you will want to keep this slide. Okay, you'll want these rules. You'll want to use these rules for your homework, for your quiz, for your writing assignment. So go ahead and make sure that you open this up so you can save it, screenshot it, take a picture of it, write it down, whatever works for you. I'm going to go ahead and cover up some of these, but this is a list of all of the possible translations. Okay, the first translation we're going to talk about, and if you want to make any notes on your class kick assignment, go ahead and make any notes that you need to. All right, so a horizontal shift. Horizontal means that we're moving left or right. Okay, horizontal refers to the x-axis. So this is when we're going to take our original parent function and we're either going to move it to the left or to the right. This one is probably the trickiest one because in our minds, if we're moving left, we would be subtracting, but it's actually the opposite. So if you look here, when the function inside the parentheses has x plus a number, if it's adding a number to x in the parentheses, so we're adding to the input, we're going to shift left. So this might look like, whoops, let me use a skinnier marker. Okay, so this might look like f of x equals, we would probably have like x plus 2. This means the parent function has shifted to the left 2 units. Similarly, if we have a number being subtracted from x in the input in parentheses, we're going to be thinking that we're going to the right. So that would be like x minus 2. That would be going to the right 2 units. Okay. So just like we can have horizontal shifts where we're going left and right, we can also have vertical shifts. And this one tends to make a little bit more sense. So a vertical shift means that we are shifting up or down. Okay? This time, the difference is that we are adding a number, okay, outside of the original input. So this addition and subtraction that takes place does not happen inside the parentheses. This is not inside parentheses. Okay, so that's the biggest difference there. So if we have, if we add, that means we're going to shift our function up. So f of x would equal x, and then we would have plus 3. That would go up 3 units. Okay, notice that the adding or the subtracting is not happening inside the parentheses. It's happening at the end. Okay, and this makes more sense to us because in our original slope-intercept form, we have y equals m times x plus b. Up and down, this is our plus b. So this makes sense, right? If we had a positive 3, we're at a y-intercept of 3. So we just moved up 3. Okay, this one you probably are like, oh yeah, that makes sense based on what I know about graphing. Okay, now we have something called a reflection. So think about like a reflection on water or a mirror. Okay, it's like if you were to fold it in half, like in art class, we talk about like symmetry. Okay, if you were to fold your paper, we used to call it hamburger style. Okay, so you fold it. If this is the X and Y axis, you're going to fold it the top down to the bottom. So the X axis would be our fold. Okay, that happens when you put a negative in front of the entire function. You're going to reflect it across the X axis. If your negative sign is just related to the input, not the entire function, just the input is negative, that's when you're going to fold it across the y-axis. like a hot dog. Okay. And I'm gonna show you exactly what these look like in later slides. I just want to go over how to read this rules chart. All right, now we have some compressions and stretches. The first thing we have is a vertical stretch or compression. So if we change the slope of the function, Amari, good question. So f of x and g of x are different because f of x always means the parent function. G of x means something has happened to the parent function that now it needs a new name. That's why we call it g. So with a vertical stretch or compression, if the slope in front of x is bigger than 1, okay, and we're talking absolute value. So even like if we have -2, we're looking at the negative sign. Or sorry, we're looking at the 2 because the negative sign denotes a reflection. So we're just looking at the number, not if it's positive or negative, just the number. If the number is bigger than 1, it's going to be a vertical stretch, which means it's going to get, our slope is going to be steeper. I'll type that in here. Okay, our slope becomes steeper. Okay, if the number in front of your x, if a is between 0 and 1, so if it is a fraction where the bottom number is bigger than the top, it is going to become flatter. Okay, it's going to look more like a flat line. Okay, so that's called a vertical stretch or a vertical compression. Sometimes we call them shrinks instead of a compression. You might think of it as shrinking the line. And then lastly, we have horizontal stretches and compresses. Okay, so if the number A happens inside the parentheses, just like this top one has the word horizontal and it happens inside the parentheses, same with the bottom. If it happens inside the parentheses, it's horizontal. So if it is smaller, if A is greater than 1, okay, it's going to be a compression. So this is backwards. Just like the horizontal left and right was kind of backwards, this one is also kind of backwards. So you can see it's not hard rules, but there are a lot of rules. So that's why I want to make sure that everybody opens that class kick. So you have this set of rules to use, okay? So if A is greater than 1, it's going to be a compression. If A is less than 1, it's going to be a stretch. Sorry, if A is between 0 and 1. So if it's a fraction. Okay, I know that seems like a lot, but let's take a look at how this looks on a graph. So the first thing we're going to do is take a look at this one. This is the first example. We have the graph of f of x equals x. That's our parent function. That graph is in blue. As you can see, it has a y-intercept of 0, so it starts at the origin. Our slope is 1 over 1. So I go up 1, right 1, up 1, right 1. Okay, the blue line, this is our parent function. It asks us to describe the transformation from the graph of f of x to g of x. Well, let's look at what g of x is. It says g of x is x minus 5. Okay, so what's happening? I'm subtracting 5. I'm asking myself, is it inside or outside parentheses? Outside the parentheses. Okay, there's no parentheses here. So if I go back to my rules, it is outside the parentheses. So I'm looking at a vertical shift down because I'm subtracting. Okay. So if it asks me to describe in words, here we go. The graph of g of x is the result of translating the graph of f of x 5 units down, or you can say it was shifted down 5 units. And you can see that, right? Blue and red, those are the same line, they're parallel, but the red one we just moved down 5 units. So that's what a vertical shift looks like. This is a vertical shift down. All right, now let's look at, actually, hold on, I want to do this one first. No, wait. This one. Okay, so what if I did x plus 5? Where would my y-intercept be? Can you tell me in the chat? So this is the graph we just did, but now I want to know, what if I have h of x equals x plus 5? Where would my y-intercept be? Let's graph this one in green. Good, Amari. Okay, good. Yes, so my y-intercept would be at 5. What would my slope be? Yes, exactly. The slope is going to be the same. Okay, when two lines have the same slope, like you learned in your lesson on 4.01b, we call those parallel lines. Okay, so these three would be a family of functions. The blue one is the parent function. Okay, the green one was translated up 5 units. The red was shifted down 5 units. Okay, so here is that same thing written out in words. A vertical translation is made by adding or subtracting a number to the function. So if I add 3, I'm going to go up. If I subtract 5, I'm going down. If you have a vertical or horizontal shift with a okay, Nalani, we're actually going to do some of those in our example problem. So give me just like 5 more minutes to get through, and then you'll see. Okay, it's in the class kick slides. I'll show you how we write that. Okay, good question. Okay, so a horizontal shift. Oops, I skipped a slide. Here we go. The parent function here is shown in red. Okay, so when this is supposed to be in parentheses. Sorry about that. No, wait, here it is. Sorry. Here's horizontal. We have x plus 3. So remember, this is where our mind wants to tell us to go right, but it's a horizontal shift. It's happening inside the parentheses. It's happening to the input. So green line is our parent function. We have the line y equals x minus 5. It's happening inside parentheses, so it's horizontal. So that means it's going to be moved to the right 5 units, and there's our line. In blue, we have y equals x plus 4. It's going to move to the left 4 units, and there's our same line. It's the same line, same slope. We just have changed the input. Okay, so horizontal and vertical shifts look kind of similar. The slope is going to stay the same. The slope is going to change when we talk about a reflection. So a reflection on the x-axis is made on a function by multiplying the parent function by a negative. So we're taking the entire parent function and making it negative. What does that look like? Okay. Oh, wait. I think I said blue, but I meant red or green. So the red line is our parent function, right? Here's 0, 0. Here's 1, 1. Here's 2, 2. So think about it. We're going to fold it over this dotted line. This is a reflection over the x-axis. So that means where this original red line is, when I fold it in half and reflect it, now it's up here, the green line. Okay, this is how we get our new line. The funny thing with linear reflections is that even if I were to fold this and do a reflection across the y-axis, I'm actually still going to get the same line. Okay, it's still going to be negative. That's only for linear functions. Okay, so if all of a sudden your function goes from positive to negative, it is a reflection over the x-axis. All right, let's talk about some shrinks and stretches, and then we will get to working some problems together. So a stretch is made on a parent function by multiplying the parent function by a number of for x that is greater than 1. And these bars mean the absolute value. So what I mean by that is don't pay attention to the negative number, the negative sign, because that indicates a reflection, like we just talked about. We're just looking at the number itself. So if I have y equals 3 times x, this means my slope went from 1 to 3. Okay, sometimes people like to think of a stretch as like a narrowing of the graph. Let me show you a picture and that might make more sense. So the blue line is the stretch or narrowing. The red line is the parent function. Okay, so the blue line got steeper. You can say it got narrower, but that represents a stretch. The number in front of x is bigger than 1. So what is a shrink or a compression? I'll type that out in case you prefer to use that word compression. A compression or a shrink is made on a function by multiplying the parent function by a number x such that x is between 0 and 1. So it's a fraction where the top number is bigger than the bottom. For example, y equals 1/2 x. Some people also, like we thought of the stretch as a narrowing, some people like to think of a shrink as a widening. I'll show you the graph so you can see which word maybe makes more sense to you. But like we wrote on our rules, this line is more flat. So number bigger than 1, steeper. Number between 0 and 1, flatter. Okay, and that red line again is the parent function. So in the reflection, the stretch, and the compression, our slope is going to change. Okay, so how do we use all this information? What are we going to need to do? Let's go ahead now, and you're going to go to Class Kick. If you will open that up and go to slide number 2. So this is slide 2. Alrighty, so let's look at number 1. The directions for these say if f of x equals x, that's our parent function, describe the transformation of f of x to get to g of x. So f of x and g of x are different. We're going to take this one step at a time. Okay? It looks overwhelming, but all we're going to do is go one piece at a time, check back with our rules, and figure out what's happening. So if we look at number 1, let's take a look at it. It says that g of x equals negative, then parentheses, x plus 5. The first thing I know that's different from my original parent function is the negative sign. So go back to your rules, your function rules. What does it mean if there is a negative sign out in front of the function? Tell me in the room chat. What does that mean? If there's a negative sign in front of the function. Yes, exactly. Good. Good, AJ. Good, Nola. Okay, so then that's what I'm going to type. Reflected across the x-axis. Okay, so far, g of x is different from f of x because it was reflected across the x-axis. Then I get to the next part. So inside the parentheses, I'm adding 5. So click back on the slide. What is happening if you're adding something inside parentheses? This is going to be a horizontal shift to the left. Okay, so reflected across the x-axis, shifted to the left 5 units. Yeah, AJ, that's it. There is no solving. All you're doing is telling me in words what's happening. Yeah, hopefully this is easier than what you thought, right? Okay, let's go ahead and do number 2 together. Somewhat easier. Okay, that's fine. I'll take it. I'll take somewhat easier. Okay, so number 2, we have g of x equals, all right, here's the first thing that's different, 2/3. So this is a number in front of x, and it's between 0 and 1. So y'all tell me in the chat, what's happening there? What does that mean? Type it out on your own paper. Hey, Aubrey, are you able to type on your class kick? I can see you. Gabby, are you able to type? I don't see anything yet. Nalani, what about you? Are y'all able to type on there? Nevaeh, Paulina, Sanaya. Can y'all type on that second page for me? Okay. All right, so A is between 0 and 1. So what does that mean? Maurice, thank you. Good job. Anybody? Let's go back to our rules. If you need to go back to slide 1, that's fine. Number in front of x, that's between 0 and 1. That's right here. So this is going to be a vertical compression. So that's all we type out right here. We're just going to type vertical compression by 2/3. Okay, everybody should be typing this on their slide 2. Good, Nola, thank you. And then we have subtracting 4 at the end. So the subtracting by 4 is not in parentheses. So this means it's going to be a downshift. Okay, so it's going to shift down 4 units. All right, what I want you to do, I'm going to give you 2 minutes, and you are going to do number 3 on your own in class kick. I want you to raise your hand when you've got it done or when you've got one part of it done so that I can help you and give you some feedback. Okay, so you're doing number 3 on your own. We'll do one more together, and then we have another slide that I want to show you. Use those rules on your first slide to help you. Yes. Marley, good job. I'm going to leave you a smiley face. Good job. The next one we're going to try, Marley, together is number 8. So if you want to try that one on your own, you can. That's one we're going to try together. We're going to finish out with that one together before we go on to one more thing. Hey, AJ, this one actually is not in, I didn't assign it to you. So you can just use this link and log in as a guest. But if it's not working, I need you to send me in a private message, send me your student ID number so I can reset your password for you. Yay! Amari, good job. You did it, girl. Okay, what else? Anybody else ready for me to check? Gabby, how are you doing? Okay, Nola, so let's take it one step at a time. You have right. Shift it to the right 2 units. Yep. And then instead of up 4, it's just going to be up 3 because that's your number. But you've got it. Yeah, you're good. If you want to try number 8, that's what we're going to do next is we're going to work on number 8 together. All right, so for number 3, the one I just had you do on your own, inside parentheses, we're subtracting 2. So that means it's going to be a horizontal shift to the right 2 units. And then we added 3 at the end. So then it's going to be a vertical shift up 3 units. Okay, so double check your answer. If you didn't finish, that's okay. I want to do number 8 with you. If you want to work on it in class kick and try to beat me, that's great. But this one has 4 transformations that's happening. So I want to make sure that we go over this one together. So for number 8, the first thing we come across is a negative sign outside of the entire function. Okay, so a negative sign means that I'm going to reflect. It's a reflection across the x-axis. I'll change this to black. There we go. Then I have the number 4. 4 is greater than 1. So that's going to be a vertical stretch by 4. So all I've done so far is take care of the negative. I've explained what the negative means. And I've explained what the 4 means. Now, let's take care of what's in the parentheses. If I'm subtracting 2 in the parentheses, that means it's a horizontal shift to the right 2 units. And lastly, if we take care of the minus 4, that's going to be a vertical shift down 4 units. So whoa, why did that copy twice? It seems like a lot, but if you just take it one piece at a time and say, okay, what does the negative mean? Okay, let's write that down. What does the 4 mean? Okay, let's write that down. Okay, so just take it one step at a time. Maurice, I'm going to leave you a little bit of feedback for number 3 on your page. Okay, so what I want to do with the last 5 minutes is talk about what if you all will go to slide 3, what if we are asked to write the equation ourselves? So they gave us the word description of what's happening, and now we are responsible for writing the new equation. So we're going to let all of these, we're going to do a couple together. We're going to let them be g of x, okay? So I know that the original equation is just f of x equals x. So I'm going to go ahead and put my x there. Okay, so everybody go ahead and put your x on number 11. So this says a reflection across the x-axis. So if I go back to my rules, I'm going to read the description on the right-hand side, right-hand column, reflection across x-axis. So what does that mean I'm going to do? I'm just going to put a negative sign in front of the entire thing. So this one is easy. It's just going to be negative x. That's all. Let's try number 12 together. A vertical stretch by a factor of 4. So let's go ahead and write out the new name of our function, g of x. We're going to go ahead and put our x in there. All right, a vertical stretch by 4. So go back to your rules. Where we have vertical stretch, I have to ask myself, is a bigger than 1 or between 0 and 1? It's bigger than 1. Okay, so I'm just going to write that number 4 out in front. So this is 4x. All right, what if we want to do more than one translation? Let's look at number 17. So g of x equals, and I'm going to leave myself some room here. So let's look at number 17. A vertical compression by a factor of 1/3. Okay, so I know that 1/3 is going to go out in front. Translate 1 unit to the right. If I look back at my rules, when I am moving to the right, it has to be in parentheses. So I'm going to subtract the amount I'm translating to the right by. This one I'm translating 1 unit. So this is going to be -1. And then 10 units up. So I'm going to add 10 at the end. Okay, so for your exit ticket, I want you to do number 18 on slide number 2 and raise your hand when you've got it. And I will let you know if you've got it and you're good to go. Or at 10:45, I'm going to go over this one. I'm also sending out an email to sign up for small groups this week. So tomorrow's small group at 10 and Friday's small group at 10 are going to be over the linear transformations. So over 4.02. The 9 o'clock small group on Friday is going to be over 4.01 and 4.01b. Okay, so you're going to get another form where you can click on it. You can click sign me up or you can click no thanks. If you click no thanks, I'm going to make it optional in case you decide at the last minute that you'd like to join anyways. Okay, so go ahead and raise your hand when you've got it, got number 18, or when you think you have it or part of it, and I'd be happy to take a look at it. Good, Marley, you're just missing, let me highlight it or underline it for you, the part that you're missing. What does it mean if it's reflected across X? You're missing a tiny little sign, but otherwise you did perfect. So Amari, same. Inside your parentheses, let's leave the X as positive and just move it to the outside. Otherwise, you did perfect. Good job. So if you have not taken your quiz in the lesson 4.02, go ahead and go do that in the course. Let's see. There you go, Marley. Good job. Good work. Perfect, Nola. Good job. You're good to go. Good job. Good job. Sanaya, how are you doing? Paulina, I can see you, but I don't see anything written on your page 3 yet. Nevaeh, are you doing all right? Bye, Nola. Nilani, how about you? Maurice, I think you're checking on your rules. That's good. Aubrey, close. I think maybe you mixed up a number here, but the left 7, that's right there. Good. Factor of 2. Good. I think this is supposed to be a 4. So plus 4 at the end. And then don't forget about the reflected across the X. So you're just missing a tiny little sign. Anaya, how are you doing? I see you're getting ready to start working on it. Good job. I'm missing a hand, I think. Someone's got their hand up. All right, I'm going to go ahead and go over this one in, no, Paulina, just number 18 is what I wanted you to do for page 3. I was doing a couple with you. This is here, though. If you wanted a little bit of extra practice before you take your quiz, you can use this. So let's go over number 18. It is a vertical, okay, so first of all, let's rewrite. G of x equals, okay, we're going to have our x. A vertical stretch by a factor of 2, so I'll put my 2 out in front of x. Translated 7 to the left, so that's going to be plus 7 in parentheses. Up 4, so I'm going to add 4. And then reflected across the x-axis means I'm going to have a negative sign out in front.